morning friends. In this lecture I am going to solve problem which can be reducible to standard form 3 students. Important problem. Let us see. Solve z square into p square plus q square that is equal to x square plus y square. X square plus y square. See students, here by observing the terms here we have p, q, x and y students. P, q, x and y. What is the extra term here students? Z. Extra term is z student. So that by observing here standard form 3 we have xp, yq. Okay students, xp, yq. Okay, so I can reduce this problem into standard form 3 students. Standard form 3 by observing the problem students. Okay, see how can we reduce students? By a suitable substitution. Let us see students. Solution multiply with z square students. I get here z square into p square plus z square into q square that is equal to x square plus y square students. X square plus y square. Now see students, here z square into p square means dou z by dou x. Dou z by dou x whole square students. So I can write here z into dou z by dou x whole square plus q means dou z by dou y whole square students. That means I can write here z into dou z by dou y whole square. That is equal to x square plus y square. X square plus y square. Now say students, I want to write z into dou z by dou x as dou z by dou x students. Dou z by dou capital X or dou capital Z by dou small x. By a suitable substitution students. By a suitable substitution. Okay students. So let or put capital Z that is equal to, I want to get this form students, z into dou z by dou x. Okay, z square, small z square by 2 students. Whenever I write capital Z, say equivalent symbol students here. Okay, or you write z is small z students for denoting small z. Okay, now simply I want to find dou z by dou x students. That implies I want to find dou capital Z by dou x. Come on, tell me students now. Differentiating with respect to x students. We know z is function of x and y. Z is function of x and y. So I can write here 2z divided by 2 into dou z by dou x. Dou z by dou x. 2 cancel students. I get here small z dou z by dou x. Now z into dou z by dou x value students, dou capital Z by dou small x. Okay, see students, here z into dou z by dou x values dou z dou capital Z by dou x. Okay, similarly dou z by dou y students, dou capital Z by dou y. So that is equal to again 2z by 2 into this time students dou z by dou y. So 2 cancel. I get a z into dou z by dou y. Now finally z into dou z by dou y means dou capital Z by dou y. Z into dou z by dou x means we get here dou capital Z by dou x. Say this is 1 students, 1. So substitute in 1 we get, substitute 1 we get, what time students now? Dou capital Z by dou small x whole square plus dou capital Z by dou y whole square that is equal to x square plus y square. Simply say students here capital P square plus capital Q square that is equal to x square plus y square, where capital P is a dou capital Z by dou x and capital Q that is equal to dou capital Z by dou y. Okay, so now see students, it is like a xp yq students. That means all the terms contains capital P, capital Q, small x, small y students. So what is form students? Standard form 3 xp yq. So I want to rearrange the terms here, students, as standard form 4. You transpose x square to the left and q square to the right, students. So you get here capital P square minus x square, that is equal to y square minus q square, students, minus q square. To find the solution of this given problem, students, say that is equal to a square, students, because I have a square, students, so that I want to take a square, say. Okay, now take first one, students. So p square minus x square, that is equal to a square. That implies I want to find capital P, students. So capital P square, that is equal to a square minus x square. So that implies capital P, that is equal to, students, square root of a square minus x square. A square minus x square. Now similarly, second one, students, y square minus q square, that is equal to a square. Now q square, students, capital Q square, that is equal to here capital Q square. So you get a y square minus a square. So capital Q, that is equal to, students, square root of y square minus a square. A square minus a square. So students, here whenever we transfer this side, we get plus, students, here plus. Okay, now we know that here d what we have, students, here capital Z, students, don't forget. Here you don't forget, students, we have here capital Z. So you write here d capital Z, students, capital Z. So that is equal to, what is solution, students? Suitable solution, p capital P dx plus capital Q dy, that is equal to, what is capital P, students? What is capital P? Square root of a square plus x square into dx plus capital Q, students, square root of y square minus a square into dy. Simply integrate, students, integral of d capital Z, students. What, students? Capital Z. Don't forget, students. Integral of square root of a square plus x square into dx plus integral of square root of y square minus a square into d. Now integral of d capital Z, students, capital Z, we get here capital Z, that is equal to we have a formula, students, square root of integral of square root of x square plus a square into dx. What is formula, students? What is formula? Come on, tell me. Okay, x by 2. What, students? You write as it is, students, square root of a square plus x square plus see, students, we have a square, students, so we get a square by 2, okay, sine h inverse x by a, students, plus this time I have y square minus a square, students, not x square minus a square, y square minus a square, students. So you write in terms of y, students, in terms of y. So this time we get a formula, students, y by 2. Okay, students, y by 2. Write as this, students, square root of y square minus a square plus students, here no, it is a minus a square by 2. This time we get here, students, into cos h inverse y by a, students, plus b. Okay, see, students, I have capital Z, students, here, but we need to find Z is equal, students. So where is the capital Z here? Capital Z, students. So Z is equal to Z square by 2. So write here small z square by 2, that is equal to x by 2 square root of a square plus x square plus a square by 2 sine h inverse x by a plus y by 2 square root of y square minus a square by 2 cos h inverse x by a plus b, students, which is the required solution of given problem. Once again, students, I observe the terms here, students, p, q, x and y. Okay, what is the extra term here, students? Z square. So that I can reduce this problem into standard form 3 by a suitable substitution, students, by a suitable substitution. So that what I am doing here, students, I multiply with z square. Okay, then I get the form here z into dou z by dou x whole square, students. Okay, now when I get z into dou z by dou x, students, when I get z into dou z by dou x, so capital Z, that is equal to z square by 2, students. Okay, students, suitable substitution, z square by 2, because when I differentiate z square, I get 2z, students. 2 to cancel. Again, we know z is function of xy, so I get dou z by dou x. So finally I get z into dou z by dou x. Is that clear, students? So I am taking a capital Z is equal to z square by 2. Okay, find dou z by dou x, students. We get z into dou z by dou x. Similarly, dou capital Z by dou y means I get z into dou z by dou y. Okay, simply substitute here. We get a form, standard form 3, students, capital P square plus capital Q square, that is equal to x square plus a square. Here onwards I know, students, we know that is equal to, generally we are taking a students, a is arbitrary constant, we can choose any arbitrary constant, students. So a square. So I want to write P, students, P and Q. Now C, students, this is very important, students. This is very important. D capital Z, students. Previously we write a D small z. Now this time it is a D capital Z, because here we have capital Z, students. So D capital Z, that is equal to capital P, students, capital P dx plus capital Q divide. Don't forget, students, here. Okay, don't forget. So I substitute P and Q values here. Simply integrate, students. By suitable, we know the formulas. Apply the formula. Write down the formula here. We can finally get the required solution of given problem, students. Given problem. Please subscribe this channel, students. Like this video. Share this video as many as possible, students, in our groups. Thank you for watching this video. Jai Hind.